Programming in a statically typed language is hard. Solving type errors is one of the most dreadful tasks for novice users, experts, and everyone in between. Haskell is a popular language in the academic world, and in recent years, it has gained popularity in the industry. However, it is notorious for the cryptic type errors provided by GHC, the most widely used Haskell compiler. Here, we identified 3 symptoms of unhelpful type errors in Haskell. The type errors are hard to understand. Type errors often contain jargons, incomplete sentences, and internal objects from compiling steps. The type errors are biased. In this example, the function can be fixed on both lines. It is unclear which one is the correct fix without consulting the author of the program. However, the compiler insists the error happens in one place instead of the other. The type error do not provide full context. In this example, many places can cause the type error, but only a few are blamed. We are a group of people interested in improving type errors using the power of modern graphical user interface. We designed ChameleonIDE as our answer to the problem found in traditional type errors. ChameleonIDE uses a familiar design found in many programming environments. It has a text editor window on the left and a debugging window on the right. Instead of plain text, ChameleonIDE communicates type error through a set of consistent user interfaces. These interfaces address 4 important components in the type error: the error statement, a reference to an expression in the program, evidence for the statement, and further evidence if needed. When a type error is encountered, ChameleonIDE shows 2 alternative types. Instead of suggesting one is expected and the other is actual, we simply label them possible type 1 in orange and possible type 2 in blue. ChameleonIDE computes all the locations in the program that potentially fix the type error. In the editor window, these locations are highlighted. Locations that support possible type 1 are in orange, and the ones that support possible type 2 are in blue. Benefiting from a graphical user interface, ChameleonIDE has a set of interactive features. These features enable programmers to explore and query the type error, as well as customize the level of features they'd like to see. Here, we showcased 3 interactive features. When a type error happens, it often involves multiple expressions, but generally, fixing one of them will resolve all. But which one should the programmers draw their attention to? Candidate expression cards solve this problem by presenting all the expressions as a list of cards. Programmers can choose the one they suspect containing the type error by simply clicking on the card. This will change the details of the type error to match the updated assumption. The deduction step is the ultimate tool to put the error message under a magnifying glass. Each step represents an underlying typing rule that is involved in the type error. These steps are linked by logical entailments, and therefore they can be followed with a clear narrative. We use an overlay explanation layer to describe how the locations are related to each step in a way similar to human experts. Programmers can go through the steps with mouse clicks or keyboard shortcuts. Last but not least, ChameleonIDE allows programmers to customize the level of detail and features they believe are useful. The design of ChameleonIDE is guided by a series of 4 experiments participated by real Haskell programmers. From the studies, we showed that programmers with ChameleonIDE solve type errors faster than with GHC. Also, programmers who engage with the interactive features are often more efficient than passively consuming the type error.